Hello, this is the next video in a playlist that I'm calling Complex Variables, where we're going to do a playlist on complex analysis. And we're doing background videos first, and now we're in the trigonometry portion of the background videos. And we're going to look at period, phase shift, vertical shift, amplitude, and frequency. There will probably be 3 or 4 videos in the trigonometry portion of this playlist. But let's look at some pictures first. So let's look at the sine wave, which is periodic, which means it repeats after a certain time. And that period that it starts to repeat is called the period. And if you look at any portion of the graph where it starts to repeat, that's the period. You could look at the peaks, and that's when they repeat, and the distance is 2 pi. And so the period of the sine is 2 pi. Now, the phase shift is a horizontal shift left or right. And to get the phase shift, you either add or subtract it from the variable and then take the sign. That's called a phase shift. If it's negative like this, then it's a shift to the right. If this is a positive, it's a shift to the left. So if we look at this, the solid is the original sine of x. And if we subtract pi over 2, it's shifted to the right, pi over 2. And that's called a phase shift. Now, a vertical shift is literally just moving the graph up or down, and to do that, you add or subtract something to the function. So the solid line is the sine wave, and then the dotted line is sine plus 1. So we literally just vertical shift it up 1. If it's negative, then we vertical shift it downward. That's called a vertical shift. Now the amplitude is it's the height of the wave or in either direction. So there's a maximum and a minimum, in the middle, in that distance is called amplitude. And the way to increase or shrink amplitude is a constant multiplier times the sine of x. So notice that the original sine wave goes from -1 to 1. But since we've multiplied it by 2, it goes from 2 to -2. And that's the amplitude. Oh, and actually, amplitude. So when you turn your radio on in your car, you can either listen to AM radio or FM radio. And AM stands for amplitude modulation. So as the radio wave comes to us, it's in a sinusoidal pattern. But if you modify the amplitude that's coming towards us, that's meaningful. And that's called AM radio, amplitude modulation. So the all-in-one formula for the sine and cosine function is this: y equals a times the sine of b times x plus c plus d. And it's very similar if you just use the sine function. But a in this formula is the amplitude, the min and max distance. Then b is what's called, it determines the period of the function. Remember, the period is how long it takes for the function to start repeating. And for sine and cosine, it's 2 pi over b. So the original function, sine and cosine, has a period of 2. But with that constant multiplier, if you divide it, then that creates the period for that new function. C is the phase shift. If it's positive, then it moves it to the left. If it's negative, it moves it to the right. And D is the vertical shift. If it's positive, it moves it up. If it's negative, it moves it down. So here's an example. Now, often we see, if we look at this 1.5 times sine of 4x minus 2, that's usually the function that we graph. Boom. And that's what the solid line is. But to break it down and find its period and the phase shift and etc., you have to write it in terms of that general formula. So if we factor out a 4 from both of these, then this is it. Then you can quickly see that the amplitude is 1.5, right? It goes from 1.5 to -1.5. The period is 2 pi over 4, which is pi over 2. And if you look at this, we start at 0, and then we go until it starts to repeat, which is here. It's pi over 2. And then that's what this told us. Or if you look at the distance between the peaks and subtract that, that's pi over 2. And so the period is pi over 2. Now the phase shift is 0.5 to the right. Now the dotted line is the original sine function, and notice that it has a period of 2 pi, right? That's when it starts to repeat. And here we phase shifted it to the right. So notice that the sine starts at 0 on 0, but we've phase shifted at 0.5. Now this line here, this tick, is actually at the value 1, which we'll discuss in a minute, but not now. So half of this distance is 0.5, and if you go up, that's 0, right? Because we've been phase shifted to the right, 0.5. Now there's no vertical shift, so D is 0. And so this is how you interpret that. Now the frequency is how often something happens per unit of time. Okay, and the frequency is 1 over the period, which means you can back solve for period. If you know the frequency, then you can find the period, and the period is how long it takes to repeat. So using the all-in-one formula, A times the sine of bx plus c plus d, then the frequency is 1 over 2 pi over b, right? 2 pi over b is the period. And of course you can invert and multiply, so it's b over 2 pi. And that's the frequency. That's how quickly something happens in 1 unit of time. So in the previous example, we said b was 4, right? Which implies the frequency is 4 over 2 pi, which is 2 divided by pi, which is 0.63 something. So that means 0.6 of the cycle is completed by 1 unit of time. And so let's go back and look at this graph, right? So at time 0, we're here. And then if we start this cycle and then we stop at 1, which is this tick here, we've completed 0.6 of that cycle, right? That's the frequency, 0.6. And then, the remaining 0.4 portion of the cycle would be until we get to pi over 2, because then that's the period, and that's the the complete period. Okay, so that is frequency. Now, often the general form is written in this form. It's very similar. So it's A times the sine of 2 pi omega times t times phi plus b. Okay, so A is again the amplitude, but when it's written in this form, W is the frequency of this function, right? And you can see it as, the 2 pi omega is that coefficient in front of the variable. So if you take 2 pi divided by this, you get 1 over omega, which is the period, but in its inverse, which is just omega, is the frequency. And so the frequency is built into that function. T is time. And like if you're doing time series analysis, this is often the formula that you see. Phi is associated with the phase shift, right? You'd have to factor out a 2 pi omega and then divide by, and that's the exact horizontal phase shift. B is the vertical phase shift. Okay, but we don't have to stop at sine and cosine. We could look at the tangent function, which is another trigonometric function. But here, when we look at this graph, things happen every, at a distance of pi. So the period is pi for the tangent function. It's 2 pi for sine and cosine. Now, this vertical line is what's called an asymptote. It actually doesn't cross that, right? So it's asymptotically goes to infinity, and it's undefined at that value, and then it restarts at negative infinity and then comes up this way. It's just kind of an artifact of the way R plots these. Now, the all-in-one formula for the tangent is very similar. It can be written like this, but in this formula, A is not the amplitude. And if you look at this graph, there's no maximum or minimum. It's infinity and negative infinity. So there's no amplitude when we talk about the tangent function, right? And that's because there's no min and max. B determines the period again. And since on the base function tangent, the period is pi, so using this, it would be pi over b is the new period. So you can increase its length or decrease it based upon what the value b is. C is 100% the phase shift, the horizontal phase shift. If it's positive, it shifts to left. Negative, it shifts it right. D is the vertical shift up and down. And we just went over 10 minutes, so I'm going to stop here. And there'll probably be 3 or 4 videos in here. We're going to look at some identities, some cool things that you'll see. I'll leave it vague like that, but hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.